Hey guys, in this video I'm interviewed by Rahman, a software engineer at Uber. We're going to go through the entire unfiltered interview so you can see the process of problem solving, determining complexity, and writing our code and tests. Also, only a small percentage of people who watch my videos are actually subscribed, so if you end up liking this video, consider subscribing. It's free, and you can always change your mind. Enjoy the video.
Okay, great. So today we are going to be implementing a scheduling algorithm. The question is called time planner. So basically we have two people and they want to meet for a certain amount of time. And given their availabilities, a list of each of their availabilities, the question is to find the time window in which they can meet. So
Okay.
the input looks like this. You're going to be given an array called slots A. There's going to be a list of tuples. Each tuple contains a start time and end time. And this represents a duration inclusive in which they're free. And then it's going to be start time 2 and end time 2. Okay. You're going to be given a second array, slots B, which is basically the same. And then you're going to be given a duration, which is the amount of time they want to meet for. So as an example, 8. So
Okay.
the question is, you want to output the time window in which both of them can meet. So I think we should go through an example.
Sure.
So here is some sample input and the expected output. So in this case, you can see that the second aspect of the question is you want the earliest time.
Got it.
In this case, the earliest time window they can meet is from 60 to 68.
Gotcha.
Do you have any questions?
I think overall this kind of makes sense. Yeah, it seems like I'm given two lists that have tuples inside of them. I did have some clarifying constraints I wanted to make sure I understood. So for one, are the times for slots A, slots B sorted in any way?
Yeah, they're going to be sorted in order of start time. Yeah.
Based on okay. Sorted, slots A and slots B are sorted on start time. Cool. And then, for the times, it seems like those are always going to be integers. They're always positive. Slots A and B, they're going to be non-empty.
Yeah.
Okay. Cool.
The other part of it that you can assume is that these intervals are going to be disjoint.
Integers, sorry, I didn't catch that part. They're disjoint.
Yeah, meaning, let's say just inside of the availabilities of person A, there's not going to be overlap between two of the availabilities. So you're never going to see something like this as an example. 10 to 50, and then 40 to 80.
Got it. Okay. So okay. Within a slot, they're disjoint. So you don't have to ever merge any of the values together. Sure. Values within person's slots are disjoint. Yeah. Just looking at this right off the bat, it seems like I mainly kind of just want to find the intersection between these two slot options, right? It seems like as soon as I find the first element, first duration that does have any sort of overlap, I want to just check, is that overlap at least duration long, right? And because these are in sorted order, I should just be able to go through the slots one at a time. So making that more concrete, right? It seems like I want to have these almost two pointers for one for slots A, one for slots B to keep track of which interval I'm looking at. And every time I have a few options. I think it turns into 4 cases. So the first case is that everything inside of slots A, and by everything I mean the current interval we're looking at, is less than the start time of slots B, right? So let me put this together. Using 2 pointers, we can iterate through all of the slots between the two people. We start at index 0 for both arrays, then iterate until we get through all slots in both arrays based on cases. So one, let's just call it a.end, and we're not gonna pretend we're not gonna, even though a.end this is like a specific index, we'll just say a.end it's less than b.start, right? Other case is b.end is less than a.start. And I might need to look at cases where instead of just less than, it would be less than or equal to. Maybe that's something to look at. Otherwise, I have that there is overlap, and the overlap is greater than or equal to duration. There is overlap, and the overlap is less than duration. I think that ends up being the main stuff that I'm looking at, right? So let's start with a.end is less than b.start. So let's pretend a and b are, let's actually go to b.end is less than a.start, because then I can just look at the first example. So here I see, oh, I mixed that up. That is not the case. It wasn't that. I think I'll have to make a separate case actually, just to demonstrate this. Let's say a is equal to 1, 2, 5, 10, and then b is equal to it's gonna just be 5, 10, right? So in this case, right off the bat, I see that the end value for a is going to be less than the start of b, so I know that I can ignore this entire interval, because there's definitely no overlap that happens here, right? And then the inverse of that is if I see, if I just make this b, oops, if I just make this b and this one a, same thing applies. Now, how do I check for the overlap? And then what it should be is a pointer plus 1. Otherwise, b pointer plus equals 1. Yeah, how do I check for overlap? This is where, the example that you gave might be helpful, because I see right off the bat here that there is overlap, right? So I think what it should be is maybe the, I should be able to check that the one is inside of another. Is that the correct way? No, that's not always true. If I break it down, it's that one is inside of the other, or the end of one is greater than the start of the other one, and that's how I know that there's overlap. But I think there's like a way you can simplify that logic. So overlap means one a is inside b, or b is inside a, or a.end is greater than or equal to b.start, or b.end is greater than or equal to a.start. It should be strictly greater than, I think. Unless I think, this is something I should clarify for the constraint. So what if the duration is 1 and they have a 1 meeting time? Does duration 1 here mean that you go from 60 to 61?
Yep.
And so the overlap needs to include 61.
Yeah.
Okay. In that case, it shouldn't be less than or equal to. It's always I check that, a.end is greater than b.start. And then I think the overlap section, it should end up being, let's see, the max of between both the starts, max of starts followed by the min of ends. That's the overlap section. And then from that, I can determine if it's greater than or equal to duration. If it is, then I found the earliest start time. I think that's the rough approach. There might be something here with the overlap that I think I can simplify, but maybe I can get back to that in the code. And it might be more obvious after, I write sections of it. But overall, if I try to solve this, I know that this is going to end up being, big of n plus m runtime complexity, where n is the length of slots A, and m is the length of slots B, and then, this is pretty much constant space complexity, because I should only require those 2 pointers.
So I didn't quite catch, all this makes sense, but what about the breakdown of the 2 cases here?
Yeah, when I'm saying that there is no overlap, I'll calculate the overlap section by using, the max between the 2 starts on that interval and the min between the 2 ends. And then I should have a duration right there, right?
Yeah, and so then what?
So then all I should have to really return is, return max of starts, plus duration, right? Is pretty much how it goes.
But what if it's what if this min of ends minus max of starts is not is less than duration? Then what?
Yeah. So in that case, I see. You're talking about how I would move the pointers forward, right? Yeah, I was saying that if it's less than the duration, then obviously that's not a meeting point, right? I think I can move up either. Is it either of the pointers? No, I don't think that's true. I think I have to move up the pointer that has the lower end. Move up the pointer with the lower end value. Is that correct? That sounds roughly right to me. Yeah, because then that means you've gotten rid of the. Actually, I think if it doesn't match up, you should be able to move either of them. Yeah, you should be able to move either of them, because the next, loop is gonna check, all the other cases. So really, you can move either of. Okay, maybe just to be safe, we'll just say move the pointer with the lower end value. Though
Yeah,
I don't think that's necessary.
I think this is right. Yeah. You can come up with a counterexample for the other. Where you can't move the other one, let's say. But this algorithm seems right to me. Yeah.
Sure. I guess given like this, is it okay if we code this out?
Yeah. Runtime space looks right to me. Let's go ahead and code this out.
Cool. Okay. Let's see. Def earliest meeting time. Pick slots A, slots B, and then one thing I didn't ask is if it's guaranteed that there always is a meeting time.
There's not guaranteed to be a meeting time.
So I guess in the case of no valid meeting time, would I just return something like -1, -1?
You can return a empty list.
Okay, return empty list. There is no earliest. Sure. Okay. Okay, so what we said we'd do is we'd start off with 2 pointers, which is the A and B pointers. So those are both going to start in the beginning, and basically we want to go through and iterate until there is a point, until there are values left to go through, right, in the array. So while A pointer less than len slots A and B pointer is less than len of slots B, a val is equal to slots A of pointer, and then we have b val is equal to slots B pointer. Cool. So let's just do this exactly as as we had in the cases. One thing to simplify this, is it okay if instead of using tuples if I modify the input to use a separate class that has like a start and end value, just to make the code simpler
let's
to
not
read.
change the input. Yeah,
Sorry.
let's not change the input format.
It's not like it's just a way to make the code easier to read. So instead of me doing like eval of 0, it would just be eval dot start, just so that this is a bit tidier.
I think we should just keep the input that we have. You can instead, expand it further to be like, maybe have min A, max A here to keep track.
Mm-hmm.
But I very much strongly prefer keeping the input that we
Sure. Okay.
sort of defined in the beginning.
Sure. Yeah, I guess in that case, my first condition is, if the eval, the min value, the max value is, greater than the val of the min value. Oops. In that case, we should be able to move up a pointer, and then similarly, bval is greater than eval, then we can move up b pointer. One thing I want to make sure is it possible for this to ever get out of bounds? No, because we iterate through and only go while both a pointer and b pointer are within bounds. So even if there are different lengths, a slots and b slots, this shouldn't be a problem. Cool. So what that leaves us with is the cases of just put continuing, so I don't have to do more branching. This leaves us with the cases of where we find an overlap, right? So we can say that the overlap section, let's see, there's multiple. And I said maybe there might be a way to simplify this, right? So let's think about the max of starts and then the min of ends. I think by definition, if A's inside B or B's inside A, the max of starts, min of ends accounts for both of those. So I can remove this case here, not required as a case. Same as min max, and then if A of end is greater than B dot start, or B dot end is greater than A dot start. Which case was that? Let's see, A dot end, let me go back up. I think that's also accounted for by the max of starts, min of ends. I think by definition, when you use the max of starts, min of ends, that is the overlap. So I think I can just go ahead and try that, and maybe we'll go through some test cases to see if we can find a counterexample. So let's make this section end up being gonna make it the max of the starts. Oops. And then the min of the ends, right? And what we want to do is check if the difference between if the duration is, I forgot in my function definition, duration. If overlap section of 1 minus overlap section 0 is greater than or equal to duration, then we have found our overlap section. We can return let's see, overlap section of 0, overlap section of 0 plus duration. Otherwise we just continue, right? So thinking this through, I think that covers the cases that I talked about. There may be a mistake here with the overlap sections, but I think maybe we can go through some test cases to see if like, do we need the a dot end. So test. Do we need that condition we have? And I'm thinking a dot end greater than b dot start. I'm trying to think back to which test case actually I said this applies to, right? A dot end is greater than b dot start. Isn't that already one of the other cases? Oh no, it's greater than, not less than. Okay. Yeah. I mixed it up in my head. So if a dot end is, but that's just the opposite. No. These are completely different. Let me actually just come up with a case for where this is so it's more clear. So here, let's say I have 1, I have 10, 20, right? And then B, it's greater than B dot start, so I have, and you can't hit the other conditions either, right? So it has to be slightly overlapping. So let's say that this is 11 and 19. Yeah, it seems like this is exactly a repeat of the what I have on line 40, where I just take the max of the starts and the min of the ends, because here a dot end is bigger than b dot start, but the overlap section is super clear. And even if I do something like I make this 50, the overlap sections are still going to be that condition of the max of starts and the min of ends. So
I think this looks pretty good. One of the reasons I wanted to keep the input the same as how we defined it is I do want to run this code.
Mm-hmm.
But okay. How about we go ahead and use the example, and you can run through it like mentally, and then you can actually run the code with that example input.
Got it. Oh, I can't. Oh, sorry, I thought it was still on a Mac, so I was trying to copy and paste with a command. I'm like, why is the keyboard not working? Oh, I think I did it again.
No worries.
Oh, no, my bad. It's because I forgot I have the Vim key bindings. That's why I can't copy and paste. Huh, weird. Normally you're supposed to still be able to do that. Cool.
You know that I think you changed the input there just so there's an 8.
Sorry? Oh, yeah, it's supposed to be, right, 8. Meeting time of slots A, slots B, and then duration. So before, running it, actually, I can run through it by hand. So just to verify, yeah, so there are some conditions we didn't account for here, looking at it right off the bat, is, if slots A or B are empty, I'm assuming they're always going to be lists, so they're not none. If they're empty, in that case, I can just, terminate here and return the empty. But maybe that's not really required, because in any case, my loop isn't going to run if they're empty lists. Yeah, they won't run. So I guess in terms of correctness, it's still fine. Okay, so let's go ahead. I have A pointer, B pointer, both at 0, 0. I see that those are less than the length because the lengths are 3 and 2. So I start off, I get my A val is going to be 1050, and my B val is 015. The first thing I check, if the A val of 1 is greater than B val of 0, A pointer plus equals 1. There's clearly a mistake here. This is supposed to be the opposite. This is supposed to be the opposite. Let's see, if the end is less, yeah, I got these backwards. It's supposed to be that if the end value is higher than the start of the other one, then I would move the A pointer forward. So here, like, I see that the n value is not less than 0, so we ignore it. Similarly, the n value of b-val is not less than 10, so we don't go through that loop. Now we try to find the overlap section. Looking through this seems pretty reasonable to me, except oh no, it's right. We take the max between the first two, 10, and then the min between the other two, which is going to be 15. So now my overlap section is going to be 10, 15. The one thing I really want to make sure is correct is that I don't have some off by 1 somewhere because of something I did.
Yeah,
I think that part is okay, just because these values are inclusive and not exclusive. So when I do the greater than or equal to duration between the end and start, I'll see that I have 5. That's not greater than the duration, so I don't return it. And so the thing I missed here is otherwise, right? What do I do? And that was supposed to be that I'm gonna move up the pointer with a lower value. So, but then again, is that required, right? Or can I just move up 1 arbitrarily? Let's see what happens if I just move up 1 up arbitrarily. Though we know that moving up the pointer with the lower end value is definitely going to be correct. So here, and it's good that I actually used a pointer. So if I move it up arbitrarily, the problem with doing that, it seems, is that if I have the higher end value inside of a pointer, my next value inside of slots B might actually be still within that range of the original previous value. So that's the counterexample. Like, I guess to make it more concrete, is what happens if the next thing up here is 16 to 49, right? Is the next thing inside of B slots, and that would be the counterexample to show that you can't do this. You can't just move it up arbitrarily. You do need to go ahead and say move up the one with the lower end value.
Yeah, that sounds right.
So let's see. A of 1, oops, 1 is less than eval. Could also be less than or equal to. It could be. Is that true? Yeah. In that case, I will move this up. Otherwise, b pointer plus equals 1. And for the case where it's equal to, in that case, it can be arbitrary, and it doesn't matter. So, cool. I guess continuing with the example. So, yeah, I see that my initial thing of duration doesn't work out. I actually don't need this else here, just to avoid nesting. I check if a val of 1 is less than or equal to b val of 1. It isn't, so then therefore b pointer goes up. So now I'm looking at 60, 70. Over here, it's very clear that there's 0 overlap, and I end up hitting the next case of my a val of 1 is less than b val of 0. So a pointer goes up, continue in the loop. Now I'm checking 60, 120 compared to 60, 170. Just intuitively, we know that we're going to get to the overlap section case. And now my overlap ends up being the 60 and the 70. I see the duration of 10 is greater than or equal to the overall duration. And so I return that I should have, 60, which is the first one, and then 60 plus 8, so 68, which is terminating correctly. Yeah. And so the only thing I have to account for is, does this loop terminate? And we already talked about that earlier. We know that this does because of the conditions on the 2 pointers. If you exhaust one of the pointers in one and there's pointers left in the other one, then by definition there's no overlap. So I think this will be my solution.
Yeah, that sounds great. Let's try to run it using those sample inputs.
Sure. Earliest meeting time is not defined. Oh, it's because I didn't call it as a function. Cool. So we got 60, 68. If it's okay,
Go ahead.
I was gonna say, if it's okay to run through some examples, then I think the one thing I'd want to do is just go through maybe some edge cases instead of like manually going through, just run it in code.
Yeah, let's go through some edge cases then. Then I have one follow-up question. Yeah.
Sure. Let's see. Let's just repeat this. Easiest case is you make the duration huge. And then maybe you can make it so that one of them is empty, the other one is not. Just make the duration 0. Sorry, 1. I guess that wasn't a constraint I asked about. I kind of assumed that the duration had to be minimum 1, right? Is that fair to assume?
Yeah, we can minimum duration is 1. Otherwise,
Cool.
we can solve.
See, they're both empty. We just know that like this is definitely gonna like these two are just kind of sanity checks, but I guess intuitively we know they'll be fine. And then big one is that one of the values is significantly bigger than the other one, right? Paste this in. Let's see. 15. Let's make this one go to, let's see, 80, 90. I think that should be sufficient. Yeah. Cool. So all of the cases where we return nothing, that totally showed up fine. A big one is where the overlap is exactly, exactly the duration. So let's go to this. This are slots 8, except this only goes to exactly 68. And I kind of just reasoning about the code, I know it should be correct, but just a sanity check.
Cool.
I think those are the main cases I want to check, yeah.
Yeah, I think this code works. If you just scroll back up to like line 56, a question I have for you is, do you need lines 56 to 61?
56 to 61. Let's see. So the check I do is for the overlaps, right? When I said this would come up is if I have something like the following. Oops. I keep messing up the copy paste. Okay, so here, my max is 5, my min is 2. I guess technically no, because the overlap sections are going to be negative.
Yeah, I think that sounds right. How about we try deleting it and seeing if the code still runs?
Sure. Yeah, that seems to be totally okay.
Okay, I think this code looks perfect. Yeah, I appreciate your time. Yeah, do you have any questions for me?